Good afternoon, everyone. तो এইটো question মই এতিয়া গ্ৰুপত দিলোঁ. তো this is a question from JEE Mains. Level of the question is pretty simple. So it is. I don't think the NEET guys are required to avoid this question. This is a very good question to be solved. Okay. So like I'm expecting all answers to be in our group as soon as possible. But for the ones who are not able to solve it and who need help with this question, you may need it for various reasons. But if you need it, okay, then we will have a discussion soon. So still, I'm solving this question for you guys. Okay, what is the question? The question is, what is, okay, I haven't written the question. The question is, what is the equivalent resistance across A and B? Equivalent resistance, REQ, across A and B. Okay. So how do we proceed with some question like this? So we can have like multiple approaches, like I have taught you guys already. So what are the approaches that we are going to see through? So approach number one is like one very easy and Brahmastra kind of principle that I have taught everyone is KVL and KCL. Achha, before this, please pause this video and then try to solve this. If you are like if you got into this video by accident or something like that, please try to solve it. Very easy question. So I don't know how it came in JEE Mains. Okay, but it did come. Okay, so okay, okay, fine, pause this video now. Like for the ones who have already played, approaches is like approach number one is KVL KCL, and what is approach number two? Approach number two is your finding the equivalent resistance method, I will call it. So since I see it as a very simple question, so I am going to apply the equivalent resistance method in this question. Okay, but like for the ones who want to also solve it applying KVL KCL, you'll have to first apply a battery across these two. Only then you'll be able to find out the equivalent resistances. And if you really want me to solve it using KVL KCL, please let me know. I will help you solve it using KVL KCL also. Okay, for now like copy this question. Okay, so let's get on with it. How do we do it? So first, across A and B, but it's a very good practice. I have told every one of you, it's a very good practice to also, if you have other junctions, if it seems like there are more junctions in your circuit, to be able to write equivalent resistance or equivalent capacitance, since that kind of questions, it's very useful to break it down into junctions with same potential. So this is a point that looks like a junction, this is a point that looks like a junction to me. Okay, so how do I go about it? So I'll like name this junction something, like I'll call it X, and this junction I'll call it Y. Okay, so now I'll try to draw the equivalent resistance, and then I'll try to simplify the circuit. A to B, and then A X to Y, Y to B. So I'll like write X and Y here. Okay, now so like A to Y, this resistor is across A and Y. Okay, A resistor Y, which is 4 ohms. Okay, then Y resistor B, which is again 4 ohms. Then again A resistor X, which is again 4 ohms. Then X resistor B, which is again 4 ohms. Okay, then what else? Okay, this one's 1. Okay, X to Y 4 ohms. Okay, this is all, these are all 4. Okay, now to the ones who are actually keen, and then have developed a keen eye on solving circuits, are going to be able to say that this resembles a balanced Wheatstone bridge, because R1 by R2 is equal to R3 by R4, right? So will there be any current across this resistor? No. So this resistor effectively becomes useless. Okay, then what more, there's another resistor 16 ohms across A and B. So this will be like, I'll try to draw it like this. Okay, then this is 16. Now first you can solve this part. So 4 plus 4, this part becomes 8, and then 4 plus 4, this part becomes 8. So these two 8 ohms are in parallel, so solving it by the easier method, 8 by 2, this equivalent of this Wheatstone bridge type structure or Wheatstone bridge structure becomes 8 by 2, which is 4. Now we have 4 ohms and 16 ohms in parallel, right? This whole thing became 4 ohms, and we have with it 16 ohms in parallel. So for parallel I use again R equivalent in parallel is Req. Okay, well, I'll bring it down a little bit. Req is equal to 16 and 4, right? 16 into 4 by 16 plus 4, which becomes 16 into 4 by 24. 5 times 20, 16 by 5. 5 3s are 15. 1. It becomes 3.2. R equivalent becomes 3.2 ohms. Okay. So this is our solution. Let's see if it is in one of the answers. Yes, there is one option. 3.2 ohms. Okay, hopefully you guys were able to understand. Okay, by now, with the understanding of circuits that we have gotten, I am like pretty sure that every one of you is able to solve these kind of questions. Okay, another thing, Acha, you try solving it through your KVL KCL method. Other than that, I will require you guys to solve the other questions that I'm going to post today, because I have been doing this analysis of previous year questions for JEE mains, and then from that I have there's a video coming up. I'll like show you one slide from that video. Okay, how to crack JEE mains 2024. A very good video is coming up on that. Okay, I have used a lot of AI, ChatGPT and similar kind of models to crack the code, how to get the maximum out of your next 3 months to get selected into the next JEE. So that video is coming up, and I want every one of you to solve it on your own without watching the video. If not possible, also try the KVL KCL method. Other than that, I'll meet you soon. Thank you.